Okay, so today we're going to look at the Hamiltonian paths or a cycle. So a Hamiltonian path or cycle is where you use all the vertices. So if you remember yesterday, we were talking about the Eulerian. So remember the E1 is to do with all the edges, and then now the other one, the Hamilton, is to do with all the vertices. So a path is a Hamiltonian path is when you go to every vertex in the network, but only once. So you don't repeat it, but you only go once. So every vertex. And a cycle is where you do the same thing. It's a path, but you're going to go to every vertex, and except you'll start and finish at the last one. Okay. So there it just says there. So a Eulerian trail and circuit, they are to do with the edges, and a Hamiltonian path and cycle is to do with the vertices. All right, so as I said, a Hamilton path, you visit every vertex of the graph with no repeated vertices. So they've got an example down here. So if we go through it, see I started at A, and then I go to B, I went to F, E, D, and C. So that's a path. So you just go through. Now you don't have to use every edge. You have to use every vertex though. Okay? So then if we look at a cycle here, we're going to use every vertex of the graph, and we're not going to repeat one, but we'll start and finish at the same one. So you can see here they started at A, they went to B, C, D, E, F, and then they went back to A. So that's a cycle. If you've gone to every vertex and you start and finish it. So when you can see see how it's written out like that. So when you have a Hamilton cycle, you'll see that the front letter and the end letter is the same. And then you'll see that the letters in the middle, it's all the other vertices. And you shouldn't see a letter repeated in there, except for the first and last. You shouldn't see a letter. So that's a quick way of finding out whether it's a Hamiltonian cycle. Is quickly look if it's got the same letter at the front as at the end, and then look in the middle and see that you don't have any more repeated vertices. All right. So there's, unfortunately, we had in the Eulerian, we had some certain rules. With a Hamiltonian, it's not. You just have to be able to use sort of trial and error, and whether it can be done, you just have to find out. Okay, so here we've got some questions. So let's have a look. So it says, for each of the following, identify a Hamilton path, starting at a vertex A, and state whether a Hamilton cycle is possible or not. If possible, identify one. If not possible, explain why not. All right, so they want us to start at A. So first of all, so if I'm going to just draw it with the arrows. So everyone might have different things. So I want to get to every vertex just once. So if I do that, that's a path. That's a Hamiltonian path. I've been to every vertex. So I'll write that out. So I go A to B to C to D to E. So that is the path, the Hamiltonian. They might say Hamiltonian, or they might just say Hamilton. So it doesn't matter, okay? Path. Okay, and state whether a cycle is possible. Well, is a cycle possible? No, because, and then why not? Because we're going to go back to C. So we'll say no cycle, because we will repeat another vertex other than the starting one. Other than the starting vertex. And I'll just say A, because they told me to start at A. Okay. All right. Yeah. Okay, so then let's have a look at the question B, the second one. So they're telling me, the reason I'm starting at A is because they asked me to start at A. If you're not given anyone, you can start wherever you want. But let's have a look. So what I want to do is just go to the vertices and not go to it again. So I'm going to go, I'll go out to E, to B, and I'll go around to F, through to C and D. So there's a path, so that was all good. So I'll write out that path. So I went from A to E to B to F to C to D. That was the path. Now, can I get a cycle?
Yes.
I think I can, because I got up to D and then there was a edge that took me straight back to A. So the cycle, yes. So we'll just write the Hamilton cycle. So it was the same way, and except I ended back at A. So you can see, as I said, you start and finish, and all the letters in between are all different. All right. Okay, so let's keep going. So it says identify Hamiltonian paths and cycles. So for each of the following graphs, identify a Hamilton path, if possible, starting at vertex A, and state whether a Hamilton cycle. So we're still doing the same question. So let's have a look here at this one. So I'm starting at A. I might go to D. I go down to B, up to F, to E. Now that didn't get me. I can't do that one. So I might give it another go. I go to A to C, to B, to D, to E, F. Now that one worked, didn't it? Have I done every vertex? Yep. So I'll write that one up. So I went A to C, to B, to D, to E, to F. Now, do I think I can get back to a cycle? I'm going to try. I think I can if I change my way. I'm going to go like this, up to A, and I'm going to go this way, yeah, down to there, down to D, and then do I get back to A? I do. So I can get in a Hamilton cycle, but it was different to my path. Okay, so there's that. So you can see I'm just trialing and error there. So use your pencil, rub it out, and then when you finally get your answer, then maybe get a highlighter or a coloured pen, and then really show the examiner or me what you're doing, okay? All right, let's try the next one. So we're going to start at A. So here, I'm just going to go D, up to B, to F, to E, to C. Now I'm going to go through A if I do that, so that didn't work. So let's have another go. So, all right, what's another one? I could go down to G, up to E, to F, to B.
I don't think it's possible.
Nah. Do we think it's possible?
No.
No. So we'd probably just say for this one, so not possible. And that might be just with us starting at A, okay? So it's not possible starting at A. So if I can't get a path, I'm not going to get a cycle, yeah? So let's just leave it at that. Okay, so just to go over, remember, as I said, in your tests and your applications and that, they don't tell you you're dealing with this. You have to recognise that it's this situation. So an example of a Hamilton path could be you plan your trip from Melbourne to Mildura and you want to visit all the towns, and the towns will be the vertices. So if you go Bendigo, Halls Gap, Horsham, Stawell and Oyen on the way, but you don't want to go to the town more than once. So that's a Hamilton path. Hamilton cycles. A courier leaves her depot to make a succession of deliveries to a variety of locations returning to the depot, which would make sense. You want to go out to all the shops and then come back to your warehouse. So that's a thing like that. A tourist might plan, like leave from their hotel, they go out to all the tourist attractions and then they come back to the hotel. So that's one. So this is here to help you recognize when you're in those application questions that, all right, this might be a scenario like that.